Hello, in this video we are going to talk about Vasicek and CIR models, Cox-Ingersoll-Ross model and Vasicek model. Vasicek model is slightly modified nowadays and it is called as KMV model. Moody's Analytics globally uses this model and they have bought the copyright of this model, so it is called KMV Moody's model right now. As I am speaking, Equity Ventures has acquired Moody's, so therefore they use this model globally. Now, the most important thing about Vasicek model is it checks the loan default probabilities as a joint probability. Most of the models model on independent probability, whereas Vasicek models on joint probability. Since it is modeled on joint probability, they use copula. Now, there can be Students T copula, there can be Gumbel copula, there can be Clayton copula, there can be Frank copula. They use Gaussian copula. That's again an understatement to say the affinity of the stochastic finance people towards Gaussian distribution. We are not debating whether it is right or whether it is wrong. Most of the circumstances where it is natural, Gaussian distribution to a certain extent gives us correct values. However, during black swan events or other extreme events or catastrophic events, Gaussian distribution do not give us the correct measurement. Anyhow, stay tuned in this video to learn more about Vasicek and CIR models. Now we will understand a very important model in stochastic finance that is called Vasicek model. Vasicek model is used for on the loan portfolios and it checks the loan portfolios and it uses Gaussian copula to determine correlation between defaults. So what is copula? Copula is joint distribution. So when we have joint distribution between two loan portfolios, that can be represented by copula. So Vasicek model uses Gaussian copula, where the copula forms a Gaussian distribution, and Vasicek model compares between two loan portfolios, maybe from one bank or from two peer banks, and then it tells what is the chance of the default. So let's first write down the Vasicek formula. DRT equal to K multiplied by theta minus RT into dt. This is the drift term. Very important point. And then the volatility term. There are two terms. This is sigma dWt. Now dWt, if you have seen my Wiener process video, WT is a Wiener process, which is having Martingale, Markov, IID and all of it. dWt means incremental Wiener process. That means the increment of Wiener process. Please check the Wiener process video for more details. So that is the volume term or diffusion term. So we usually call this term as the volume term or diffusion term. These models are used in real life on a day-to-day basis, and in the first part, this model is called the drift term. Drift term. So how much it is drifting? How much it is drifting from being a normal Wiener process? So normal Wiener process, how much is the drift? So dWt is obviously a Wiener process. It starts with Wt where t is equal to 0 and then it goes to t is equal to capital T. What is it? It's basically a shock. It takes a shock. It follows normal distribution. The mean is 0 as we discussed earlier and the variance is constant dt. Dt is the variance, constant variance. There are parameters such as k, there are parameters such as theta, and there are parameters such as sigma. These parameters are all time invariant parameters. All time invariant parameters means these are not going to change with time. So these are time invariant parameters. Time invariant parameters. Okay, they are not going to change with time. Therefore, Vasicek model typically is an equilibrium model. Why we call it an equilibrium model? Because in equilibrium model, we bring lot of things to rest. So there are suppose 8 or 10 variables. We put out of 8 of 10 variables, some 5 variables put to rest. make them time invariant. Therefore, the calculation and the accuracy becomes quite strong. Now, logically and intuitively, how come we make them time invariant? Because interest rate, then all the other parameters, most of the time they are either range bound in a narrow range or they are static for a given period of time. Like for a quarter, so if you are calculating inside a quarter, many of the parameters are static. Therefore, it is intuitively perfect to consider some of the variables, in fact majority of the variables, as time invariant, which further makes this model as an equilibrium model. Now the important point of Vasicek model that it accepts, it do go into the negative zone, so it allows negative interest rates. That means it can work during deflation. It allows negative interest rates. So when Japan faced a deflation, they could use Vasicek model. In fact, they used Vasicek model because Vasicek model uses deflationary scenarios because it can attract, it can accept, and it can work in a situation which can have the negative interest rate. Now we will side by side learn the CIR model. The full name is Cox-Ingersoll-Ross model. It is a close competitor of Vasicek model. So some part of the models are same. K theta minus RT dt, the drift term is exactly the same. The next term, the diffusion term, is slightly different. You can see sigma root RT and then after root dWt. So fundamentally speaking, you can see one term coming here, root RT. This term is a term which comes inside the diffusion term in a Cox-Ingersoll-Ross model, and it also has a parameter that it cannot take negative zones, therefore it cannot work in deflationary scenario. However, it goes for the same long run equilibrium value because the fundamental assumption is mostly same, and the theta comes as a convergence. So the theta converges slowly, and this is a mean reverting process. Vasicek is also mean reverting process. So Vasicek is also stationary or mean reverting. CIR is also stationary and mean reverting. Both are normal distribution, mean reverting, zero mean, IID process. Not only that, both are Markov process. Both follow pure martingales, no submartingale, no supermartingales. Whether RT is greater or lesser than theta, it doesn't make any difference here. It converges towards theta as its mean reverting nature is there, so it kind of converges towards theta. And CIR is more volatile compared to Vasicek when RT is greater than theta. So when RT is greater than theta, then CIR becomes very volatile. Then we usually prefer Vasicek. And when RT is lesser than theta, that is theta is greater than RT, we usually prefer CIR because the volatility comes down. The standard deviation of this DRT seems to depend on the level of the short rate or RT. So RT is a short-term rate. So this short-term rate is very important, and the root of this short-term rate, standard deviation of this short-term rate, this is very important for the calculation of this CIR model as well as Vasicek model. However, in Vasicek model, this is invariant, time invariant. But in CIR model, it is kind of marginally time variant. So both are mean reverting process, but Vasicek is preferred for multiple reasons, as you can understand, because Vasicek has works well in a deflationary scenario, whereas CIR doesn't work well. Both follow the Gaussian copula method. Copula, as I already told you, I'll write it again here. Copula is called a joint distribution. Joint distribution. So when we have to show joint distribution, we use copula. And the copula these guys use, they generally prefer a copula of 0, 1. What is 0, 1? 0 is obviously zero mean. N goes for the normal distribution, and 1 is the variance, that is sigma square equal to 1. And obviously this has to be a IID process, this has to be a Markov process, and this has to follow the pure martingale properties. Thank you very much for watching. Stay tuned for more videos.